Hello everyone, welcome to RDCS tutorials. In today's session, we will discuss CPU scheduling algorithms part 1. So we will cover scheduling criteria, FCFS scheduling, SJF scheduling, advantages, disadvantages and more most important points. Okay, so why CPU scheduling? Before understanding scheduling algorithms, let us first understand why CPU scheduling is required. So, in a computer system, many programs run simultaneously. Simultaneously means at the same time. For example, you may open Chrome, PowerPoint, YouTube, WhatsApp, and File Explorer. At the same time, all these applications require CPU time for execution. So, however, the CPU can execute only one process at a time. Therefore, a mechanism is needed to decide which process should get CPU access first. This is the responsibility is handled by whom? The responsibility is handled by the operating system through which concept? Through the CPU scheduling. Okay. So think about a hospital. So I will give one real-time example about the CPU scheduling. So think about there is a one example that is hospital is there. There is only one doctor is there in the hospital. How many doctors? Only one doctor is there in the hospital and many patients are waiting. Okay, na? There are many patients are there, but the doctor is only one. So the receptionist decide which patient should meet the doctor first. Yes, the receptionist decide which patient should meet the doctor first. Similarly, the scheduler decides which process gets CPU time. Okay, are you getting my point? Which patient should meet the doctor first. Similarly, the scheduler decide which process get CPU time. Here, doctor is not in a hospital. Who is the main role? The doctor. So here, who is the main role? The CPU. So we want to meet the CPU. Okay, na patients in a place of patient, we are discussing with the processes. Which process will meet the CPU first? Receptionist are nothing but the scheduler. Which process will go to the CPU first? Okay. Again, I am telling the receptionist decide which patient goes to the doctor first. Similarly, the scheduler decide which process gets a CPU time. Okay. Scheduling criteria. There are different scheduling algorithms produce the different results. Therefore, we need some parameters to compare them. There are different parameters are there. These parameters we call as a scheduling criteria. These all types we call as a scheduling criteria. Scheduling algorithms are compared using what? These are the main criterias: CPU utilization, throughput, turnover time, waiting time, and response time. An ideal scheduling algorithm should maximize the CPU utilization and throughput while minimizing the turnaround time, waiting time, and response time. Okay. Now we will discuss what is CPU utilization. Okay. CPU utilization. What is the CPU utilization? CPU utilization refers to the percentage of time during the with the CPU time. The percentage of time. The percentage of time which the CPU remains busy for performing usual works. Okay. Here CPU is an expensive resource. Here CPU is one expensive resource. Therefore, we do not want it to remain ideal. Okay, na? We want to do the work CPU. So we do not want to remain ideal. For example, suppose a CPU works for 90 minutes. Okay, na? CPU is working for how many minutes? The CPU work for 90 minutes. The out of how many minutes? Out of 100 minutes. Out of 100 minutes, the CPU is work for 90 minutes. This is considered as very good. The CPU utilization is here is very good. So I will give one real-time example. There is one, imagine a school bus. If the bus carries students throughout the day, okay, na? Bus carrying students throughout the day, the bus is being used effectively. Same like here, if it is busy in CPU. If remains parked all day, resources are wasted, right? So empty bus means that is ideal CPU. Bus carrying students throughout the day, that is the busy CPU. The bus remains parked all day, that is empty bus, that is resources are wasted. Here that is CPE is ideal CPE. Okay. Similarly, a busy CPU means the better utilization. Whenever the CPU is busy, then we called as a better CPU utilization. Okay. Moving to the next slide. Throughput. Okay. Throughput measures how many processes are completed within a given period of time. In a particular given period of time, it will measures how many processes are completed. Okay, na? It is measured how many processes are completed. It indicates the productivity of the system. It indicates the productivities of the system. Whenever the high throughput is nothing but that is the better performance. High means high throughput means better performance. Here I will give an example. There is two systems are there. Okay, na? The system A completes 100 process per hour. 100 process per hour. 100 process per hour. And system B completes 200 process per hour. The system A process 100 per hour. System B 200 process completes the 200 process per hour. The system, which one is the higher? The system B is the higher. So the system B is higher throughput. Okay. Suppose a bank customer is there. The customer 20 customers served per 1 hour. So how many, the what is the throughput? The throughput is 20 customers per hour. If another counter serves 30 customer per hour, its throughput is higher than the 20 customers. Okay. This we call as a throughput. Next one is turnaround time. Turnaround time. Okay. Turnaround time is the turnaround, that is nothing but the total required time for a process to complete the execution. Again, I'm telling the turnaround time is the total time required for a process to complete the execution. To complete the total execution time, we call as a turnaround time. Okay. It starts when the process enters the system and ends when the process finishes the execution. Okay. When it is working, it starts when the process is enters and ends when the process finishes the execution. Finish the execution. Okay, there is one formula is there for the turnaround, the completion time minus arrival time. There are two formulas are there, completion time minus arrival time, and one more formula is there, turnaround time is equal to waiting time plus execution time plus input output time. Suppose you submit the clothes to the laundry shop. There is one laundry shop is there. You submitted clothes to a laundry shop at a 9 a.m. So what is the time? At a 9 a.m. and receive them back to the 5 p.m. You received the clothes from the laundry service at 5 p.m. So this is the total duration represents the turnaround from 9 a.m. to 5 p.m. How many hours are there? 8 hours. So this we call as a turnaround time. Okay. Clear? Next one is waiting time. Okay. Waiting time refers to the amount of your time the process spends waiting in the ready queue. So it is in the ready queue before get the access from the CPU. Okay. The process is ready to execute but cannot execute because another process is currently using in the CPU. Okay. Waiting time, the time spent waiting in the ready queue. Okay, I will give one example. There is some process is there. The process arrives at time 0. The CPU becomes available at time 5. Okay, na? So the process is arrives at CPU at what in a 0 time. The CPU becomes available at what after 5 minutes the CPU is available. So what is the waiting units is or what is the waiting time here? The 5 minutes is the waiting time. Okay. So one more example. There is one railway reservation counter is there. Passengers stand in a queue waiting for their time. If the time spent standing in the queue represents the waiting time. Okay. The next one is response time. What is the meaning of response time? Response time is the time between submitting a request and receiving the first response. Submitting the request and receiving the first response. Notice the response time does not mean completion time. Response time is different and the complete execution time is different. Okay. It only measures how quickly the system starts the responding. Okay. We'll give an example. Suppose you call the customer care. Okay, you are calling the customer care. After a few seconds, you hear welcome to the customer support. Yes. So the time taken to hear the first message is nothing but the response time. First, you are suppose you are calling to the customer, so immediately you are not getting the response. After a few seconds, you hear welcome to the customer support. This time taken to hear the first message. What is the first message? Welcome to customer care. You are hearing the first message is called the response time. Okay. Next one. So there are different types of scheduling algorithms are there. So the first scheduling algorithm is there FCFS. Okay, what is the meaning of FCFS? It stands for first come first serve. FCFS stands for first come first serve. What is the rule? The first arriving process executes the first. Okay, as the name suggests, so FCFS as the name suggests, the process that arrives the first gets the CPU first. Okay, FCF is a non-primitive scheduling algorithm. What is this? It is a non-primitive algorithm. Then what is the meaning of non-primitive scheduling algorithm? Which means once a process starts execution. So once the process start the execution, once process the execution, it cannot be interrupted until it completes. Until it completes, it cannot interrupted. Okay. So this will call the which principle? The first come first serve will follow the FIFO principle. We already discussed in a data structure. FIFO principle, first in, first out. Okay, which means first in, first out. Okay, we'll give one real time examples. Temple queue or ticket counter queue, bank queue. Okay, in a temple, first person entering the queue gets the darshan first. That is nothing but the first come, first serve. Okay, so I'll give an example also. So there is one example is there here for the FCFS scheduling algorithm. First come, first serve scheduling algorithm. Let us understand FCFS using the example here. These are the processes and these are the burst time. Okay. The process P1 has burst time what 20. P1 has 20 burst time. P2 has 2 burst time. P3 has 2 burst time. Since so this is what this is first come first serve. Here what is the first process? The P1 is the first process. Okay. The P1 means the P1 arrives the first, then it will goes to the CPU first. This is the chart for the FCFS. This we call as a Gantt chart. First come first serve. First P1 process will like go to the CPU, then P2 process will go to the CPU, then P3 process will go to the CPU. Okay. So this is the execution order. So what is the process? waiting time for the P1? There is no waiting time. It started from only P1. So what is the, if you go to the CPU P2 process, what is the waiting time? 20. If you want to reach the P2, 0, 20. So again, if you want go to the P2, 20 plus 2, 22. If you want to complete the P3, 22 plus 2, that is 24. Okay. So what is the order? First P1 will goes to the CPU first, then P2, and then P3. Okay, first come, first serve. Okay. For example, if here P2 is there and here P1 is there. So what is the first? P2 will process, then P1, then P3. Like this, first come, first serve. And one more example I will give you. There is a waiting time calculation. This is very, very important. UGC NET and TG said they will ask the waiting time calculation. Okay. So what is the, now calculate the waiting time. So waiting time for the P1 is what? P1 is not waiting for anyone. Yes, it will start from only the P1. So P1 is 0. And P2, what is the waiting time for the P2 is 20. So again, if you see the before diagram, or else I will draw here one more time. How many processes are there? P1, P2, and P3. So if you want to complete the CPU P1 process first, what is the waiting time for the P1? There is no waiting time for the P1. It is 0. Directly it will goes to the CPU. Then what is the waiting time for the P2? If you want to go to the CPU P2 until we finish the P1. If the P1 is finished, then only we will go to the P2. So until the P2 is in waiting stage only. Will P2 waits until P1 finish. So what is the P2? 20. 20. So what is the waiting time for the P1 to P2? That is 20. Again, there is what is the time for the P3 waits for the both P1 and P2. Okay, that is 22. So the average time calculation is 0 plus 20 plus 22 divided by 3. So why here divided by 3? How many processes are there here? 3 processes. If the 4 processes are there, we are dividing with the 4. So here only 3 processes are there, right? So we are dividing with the 3. So what is the answer? 14 ms. This we call as the waiting time calculation for the FCFS. First come, first serve. Okay. Process P1, P1, P2 and P3. So P1 waiting time is 0 and what is the burst time for 20? So P2 waiting time 20 plus 2, 22 and P3 waiting time 20 plus 22 plus 2 that is 24. Okay. So there are some advantages are there for the FCFS. Advantages of FCFS. First, it is very simple to understand. What is the first advantage? It is very simple to understand. The implementation is easy using a FIFO. The implementation of FCF is very easy using which rule? Using the FIFO rule. So what? The third, it is a fair because process are served in arrival order. So now let's discuss disadvantages. The biggest disadvantage is a convoy effect. What is the main disadvantage of FCFS is convoy effect. Suppose there is one large process occupies the CPU. Many small processing arriving later must wait. This increase waiting time significantly. Okay, na high waiting time. These are the two disadvantages of FCFS. I will give one real-time example. A supermarket. There is one supermarket is there. A supermarket customer buying 100 items stands at the counter. How many items buying? 100 items. And and stand at the counter. Behind him are three customers buying only one item each. Behind there are three customers are there. First customer buy only one item, second customer buy only one item, and third customer buy only one item. So even though their work is very small, so how many items are there? Here only one item, here only one item, and here only one item. But even though the item is small, they must wait until the customer who brought 100, who buys 100, we will wait until it finishes. Okay, na? Even though their work is very small, they must wait. This situation is called a convoy effect. Convoy effect. Again, I'm telling, a supermarket customer buying 100 items stands at the counter. The customer B, one item customer. Customer C buy only two items. Both B and C wait behind A until the A is finished, even though their items are small. This we call as a convoy effect. Okay. Moving to the next slide. SFJ scheduling. Okay. SJF. It stands for shortest job first. In this algorithm, the process having the smallest CPU burst time is executed the first. Before FCFS, we are calculating with the process. Which process will come first? That process will go to the CPU. But here, based on the burst time, we are calculating the SJF, shortest job first. Instead of considering the arrival time, the SJF focus on execution time. Okay, na? The process requiring less CPU time gets the priority. Okay. So it may be primitive or non-primitive. So we'll give an example. Imagine a doctor treating the patients. One patient's need only a bandage. Another patient requires a complex surgery, and the doctor may quickly finish the bandage case first. This is a similar to the SJF. Okay, na? There are two patients are there. Patient A simple dressing, there is a 2 minutes are there, and patient B major treatment 20 minutes. The doctor finish which patient first? The doctor finish patient A first because the time is very less. That is nothing but the shortest job first. So we'll give one real-time example with the numerical values. So the example process and burst time. So how many processes are there here? P1, P2, P3 and P4. There are four processes are there. So burst time P1 is 5, P2 is 7, P3 is 6, P4 is 2. So what is the execution order? So which is the less burst time that will execute the first? So what is the less burst time? P4 is the least burst time. Then after 2, what is the one? 5. Then P1. Now after that 6, that is P3. And after that 7, that is P2. So this is called shortest job first. Which burst time is small, that will execute the first. Okay. So therefore the execution order is P4, P1, P3 and P2. So again we need to calculate the average waiting time. So for these also we can calculate the waiting time with the formula. So what is the waiting time? How many processes are P1, P2, P3, P4? Yes. So P1. So first it will execute what? It will execute? First it will execute P4. P4, then P1, then P3 and then P2. Okay. The first will execute. So here I am adding the values 2, 6, 7 and 5. Okay. Now moving to the next slide. So P1 is 2. So first it will execute waiting time. We need to calculate the average waiting time to execute the P1 is. So P1, P4 will execute first. There is waiting time is what? 0. And P4, V1 waiting time is 2 and P3 waiting time is 7 and P2 waiting time is 13. First P4 will complete 0, then it executing the P4 2. What is the burst time? That is 2 and it is 7 and it is 13. So the average waiting time 2 plus 13 plus 7 plus 0. By how many processes are there? 4 processes. The what is the answer? 5.5 mm. So like this we need to calculate the SJF, shortest job first. Okay. So how it came 13 means, so what is the last one? P2. So if you calculate these all things, 5 plus 6 plus 2, how much? 5 plus 5, 6, 11 plus 2, 13. Okay. Like this need to calculate the average waiting time. Now we'll discuss advantages and disadvantages of SJF. Why SJF is important? Advantages: there is an optimal algorithm is there. SJF is considered an optimal scheduling algorithm. Why it is optimal scheduling algorithm? Because it produces the minimum average waiting time for a given set of processors. This is one of the most important points for UGC NET and TGCET exam. However, SJF has also a limitation is there. The operating system cannot always predict the next CPU burst time accurately. Since the first future execution time is usually unknown, implementing pure SJF becomes the difficult. Implementing pure SJF becomes the difficult. Okay. So again, I'm giving here question. Which scheduling algorithm gives minimum average waiting time? So what is the answer? The SJF. Which scheduling algorithm gives the minimum average waiting time? Okay, now this question is asking repeatedly in competitive examination. Okay. So these are the topics we covered. FCFS algorithm, SJF algorithm, advantages, disadvantages. Okay, so in this lecture, we learned scheduling criteria, FCFS scheduling, and SJF scheduling detail. If you found this video helpful, please like, share, and subscribe to RDCS tutorials. And also press the bell icon so that you never miss our upcoming videos on UGC NET, TGCET, operating system, DBMS, data structure, computer networks, and other computer science subjects. In the next video, we will discuss priority scheduling, round robin scheduling, and multi-level queue scheduling. Thank you once again for your support. Keep learning, keep growing.